The team for the JWST Space Telescope spent the week deploying various components on the next generation space observatory. On January 4th, they finished deploying the 70 feet Sunshield, which shields Webb from the light and heat of the sun, moon, and the earth. The Sunshield provides a level of protection that would be on the order of more than SPF 1 million if it were a sunscreen lotion. The next day, the team began operations on the deployment of the secondary mirror. The secondary mirror plays an important role in reflecting the light from the primary mirror to the instruments that sit behind the primary mirror. There's another 5 months of setup activities before Webb will be ready to deliver its first images. This is the James Webb Space Telescope. One of the most advanced telescopes was launched into space on Christmas Day. The James Webb Space Telescope is a collaborative effort by NASA, CSA, and the ESA. The JWST was made to surpass all the other space telescopes made, like the Hubble Space Telescope and Herschel Space Observatory. Hubble is in a very close orbit around Earth, at a point where people can go to fix Hubble if something goes wrong, while Webb will be 1.5 million kilometers away at the second Lagrange point, where no human can reach to fix Webbs if something goes wrong. Webb will have an approximately 6.5 meter diameter primary mirror made with gold-plated beryllium, which will give it a significantly large collecting area than others, and is comparatively larger than Hubble's primary mirror, which is a 2.4 meter diameter primary mirror. Huge comparison. Check this picture for a better comparison. Webb is a time machine. The farther it sees, the further we can look back in time. Scientists want to know more about the chemical compositions of other solar systems and also how our galaxy was formed after the Big Bang, or if there is even the slightest chance that life can exist anywhere else other than Earth. This cannot be captured by visible light. So, Webb uses infrared rays to capture the images, unlike other space telescopes which use visible light. So, why are infrared rays important for capturing the distant galaxies? When new galaxies are formed, the dust and fog involved in the formation will refrain any light from escaping. But infrared rays can escape this dust and fog, and that is exactly what Webb will be capturing. Here are a few different nebulas captured in visible and infrared rays. Notice how we can see more stars and more details which we couldn't see in the visible light. That is why infrared rays are so important for capturing accurate images. Webb has the largest primary mirror and the largest sunshield, which is almost the size of a tennis court, which makes Webb the largest space telescope. But NASA has to fit this into a 5.4 meter diameter rocket, Ariane 5. Ariane 5 is a rocket provided by the European Space Station, and it has the largest fairing size available. But how do we fit Webb into this rocket? The engineers designed Webb to fold like origami to cheat the fairing size. This brings us to the hardest part, deployment. Shortly after launch, Webb's solar panel and an antenna for communication were deployed. 12 hours later, there's an important engine firing which sends Webb on its proper course to reach its destination. Sometime later, the sunshield panels are lowered and the primary mirror and other mechanisms are moved away from the sunshield. There's going to be a lot of solar wind, so to keep Webb stable, a trim tab is deployed. Many people think that the primary mirror is the most important part of the telescope, but the sunshield is even more important. Webb has 5 sunshield layers, each thinner than the thickness of human hair, and have the area equal to 3 tennis courts. The sunshield keeps the mechanisms like the primary mirror cool to function properly. Webb's sunshield assembly is really complicated and includes 140 release mechanisms, 70 hinge assemblies, 8 deployment motors, bearings, strings, gears, 400 pulleys, 90 cables totaling 1312 feet of cable. All this just to keep the Sunshield under control while the Sunshield is getting deployed. First, the special Sunshield restraints are rolled out, but not all the way. Then, a set of covers over the core region are deployed. The release mechanisms free the Sunshield layers. All 140 release mechanisms have to release on cue for the Sunshield to get deployed properly. 140. First, the secondary mirror is deployed and locked into place, and a special mechanism is deployed to further cool down the mirrors. Then, a set of sophisticated mirrors help to deploy the primary mirror, which is a huge task to accomplish. All the mirror segments are put into place to form a perfect mirror, which will have the largest covering area of all the other space telescopes. All the best, Webb. Our hopes are counting on you. More updates about Webb will soon be released on our channel. Till then, bye and keep watching our videos.
A small message from Tiptop Facts. If you're watching this right now, then you watched the video till the end. Thank you. Please hit those like, share and subscribe buttons for us. See you next time. Bye.